So in 1.6, we're still talking about solving equations, but we're actually getting into some higher degree equations here. So some higher degree polynomials, if you want to think about it that way. We will still try to use that zero factor property that we saw in the beginning of section 1.5. So that is the idea of where, once you factor your equation, then you take each factor, set it equal to 0, and then try and find the value of your variable. So we'll kind of use that same idea here. So the idea is if you can't find a way to factor your higher degree polynomials, you want to do that, because factoring definitely is going to be the most straightforward, maybe even an easier method, and then get into that zero factor property. And of course, if factoring doesn't work, we'll look at some other methods. So your first equation here is x cubed minus 2x squared plus 5x minus 10 equals 0. So far we were talking about the second degree polynomial, right? Now this is the third degree polynomial. Any idea on how we can factor something like this one here? Kind of on that path, yeah. Actually, no, you want to do this like we had talked about factoring by grouping. So we will actually combine take the first two terms, factor what's common in those first two terms, and then take the last two terms and find out what's common between those last two terms.
Would you take the -2 and multiply it times -10? And then find the common factor that would add up to.
Okay, so why are you multiplying the -2 with the -10?
I saw a thing. You multiply like -2 and -10. You can eliminate. So
I would have to look and see what you would do with that, because I'm not sure how that's going to work.
Factoring by grouping. So you're going to take the common factor of each side. So separate into the common factor on the left, and the common factor on the right. After you get both of those. So right here we're going to have x squared.
For the first.
Parentheses.
Yeah.
And then that's going to just leave x.
Okay.
-2.
Okay.
And then we're going to move on to the next one. Plus. That one's going to be the common factor. That one's going to be 5.
Very good.
So now I have 5 parentheses and 5 into what? 5x. Yes. So then we're going to minus 5 into what is 10. That's 2. So now we have those. So this equals out since both of them are x minus 2. That's the first one. We take x squared in the next parentheses. Squared plus 5. Next, now we have about 1.
That's perfect. That's exactly the right way to do it. Yeah. So you are grouping, like I was saying, the first two terms, grouping the last two terms. What's common between x to the third and 2x squared? Obviously, it's only going to be the x values. Now, since my smallest exponent here is 2, so that means 2 is going to be, x squared, sorry, not just 2, but x squared is going to be our common factor. So out of 3, if 2 is on the outside, which means we're left with only 1x on the inside, this x squared is gone on the outside, which means you just have that 2 left behind. Keep the same sign from your middle here. And then between 5x and 10, of course, x is not common, so it's going to be the number 5. Take the 5 outside, and then as we was explaining, 5 is gone, which means you're left with x. 5 goes into 10 2 times. You get your x minus 2 inside the parentheses. Now remember, the idea of using factoring is, of course, we want these two parentheses values to be the same, because if they're not the same, your factoring kind of doesn't work, right? So it's a good thing they came out to be the same thing. So that's what I was kind of wondering with your explanation, like what direction were you going in?
Well, I saw a thing, because I had missed the class on Wednesday, factoring. So I was looking at videos online, and what they were showing was like you take the first, if you don't have 1 as your leading coefficient.
Oh, okay, I know what you're talking about now. Okay, so in this case, the 2 is not your leading coefficient, right? Since x to the third is the highest degree, so it's actually going to be this 1 that you would then multiply with 9. Because, you know, this is what you were talking about was you were probably just looking at x squared as your highest exponent. Yeah, so since the cube is now your highest exponent, you would be using the coefficient of the cube and not the x squared. Okay, so I can now see.
Now, where did the x squared go from the x minus 2 side?
So we factored it out. So that x squared has now actually been factored out. It's come out, and you're only left behind with that 2. It's still there, but since we're factoring it out, it goes outside, and then eventually it comes down here because we take our x minus 2, you put it together as one factor, and then everything that's on the outside goes into your second factor. So now this x squared has been factored and come down here. Yeah? And this is where now your zero factor property will kick in. So now that we have our factored form, you're going to take each of these factors and set it equal to 0 to see what kind of x values our equation will have. So that means start by taking the x minus 2, set that equal to 0, or x squared plus 5, and set that equal to 0. And technically, since this is a third degree polynomial, we should have a maximum of 3 answers. So sometimes you'll get 3 answers. Sometimes if the answers are repeating, you may only get 2, 1, or in some cases, no answer at all. So what does this guy give us, the first term, x minus 2 equals 0? Yeah, very good. You will end up getting 2 because we need to add that 2 to the other side. And you're left behind with x equals 2 from here. What's going to happen on the right-hand side with that x squared plus 5?
You get x squared equals negative 5. When then when you take the square root
Very good.
of negative 5,
Which will end up giving us now remember, when you take a square root, you get one positive and one negative root out of that. So what kind of numbers are we looking into if you have square root of negative 5? Yeah, remember?
yes, I.
Because we define I as square root of negative 1. So your square root of negative 5 can be written as negative 1 times 5. Square root of negative 1 will be your I. And then, oops. The square root of 5 will stay behind, right? Because we can't simplify 5. So you end up getting, these guys are gone. We're left with x equals plus or minus I square root of 5. So that plus or minus is actually giving us 2 answers. And then we've got our single third answer from that x equals 2. So our solution set for this guy is going to be your negative I square root of 5, positive I square root of 5, and the number 2. Okay, so just to kind of recap this, we started out by grouping our first 2 and last 2 terms. As you can see, we were able to get x minus 2 and x minus 2, so they combined together into one factor. X squared plus 5 became the other factor. Then using the zero factor property, you take this guy, set it equal to 0, take this guy, set it equal to 0. From the x minus 2, we end up getting x equals 2, so he was done. From this other side, we had x squared equals negative 5. You end up taking a square root on both sides, which gives you the positive and the negative root. So that ended up cleaning up into positive or negative I, which was for that negative number inside the radical, and square root of 5, right? So those are your 3 answers. Anybody have questions on this guy? Okay, so let's look at
On the quiz, do you need us to show our work when we solve for this negative square root on this side? Or are you looking to see how we solve?
Yeah, because the only thing is, if you make a mistake, but if I can see like how far you were able to go right, I can give you partial points.
Okay.
But if you don't have any work in there, then it becomes hard for me to give you any partial points. So that would be the only thing.
Just write that out.
Yeah, to write that out. Yeah, definitely helps me then to see what your thought process was. Okay, very good. All right, so now we have a fifth degree polynomial, right? You've got x to the fifth power equals 27x squared. So just any ideas of where you would start with this one? Yeah, very good. Always start by setting it equal to 0. Okay, so in this case, I would actually go ahead and subtract the 27x squared and move it to the left-hand side. Okay, so we subtract that. You end up getting x to the fifth minus 27x squared equals 0. Okay?
Is there any rule to which position we're going to put it to? If I put it in the order, or does it have to be after?
I don't know if it would matter if you put it in the front, but the normal practice is we always put the highest degree term first. So since x to the fifth would be the higher degree, that would go first, and then you go down incrementally. So that's kind of the rule we follow. Okay, so now that we got it on one side, we have 0 on the other side. What should we do next? Because remember, we're still trying to solve this by factoring. Yeah, because from both x squared and x to the fifth, we can bring that x squared term outside. So taking out the x squared, how many x's are you left with from x to the fifth? Yeah, subtract. So that would be x to the third, 5 minus 2. And since we took the x squared out, you're only left with the 27. And you are actually back to the 0 factor property because now we have this factored. This is the first factor, x squared, and our second factor is x cubed minus 27. Take each one of them, set it equal to 0. So taking each one of these, you set it equal to 0. And what will happen on that first one, x squared equals 0? It would still equal 0. So even if you took your square root on both sides, which would give us a positive and a negative answer, it really wouldn't matter because 0 doesn't take a sign, right? 0 cannot be positive or negative. So technically, you're getting one answer out of here, right? Even though this was a second degree term. So what that actually means is the number 0 is occurring twice, which is what we call as multiplicity. So we are saying that x equals 0 is actually going to have multiplicity of 2. Because that means it's occurring twice since it's coming from this x squared term. So you're basically getting x equals 0 and x equals 0 as your two answers. But you don't obviously have to write it down twice. And then what do you think is going to happen with the x cubed minus 27? Yeah, start by moving that 27 to the other side. So the same thing's going to happen here. You will have that multiplicity aspect, but you're only going to get one number, right? Because what's cube root of 27? Okay, you got to simplify that. Now, the beauty of cube root is it's an odd root, right? It's not square root like an even root. So you're actually going to only get one answer. With square roots, you get the positive and negative. With cube root, you don't. Yeah, very good. So remember the idea behind cube root is what number multiplied into itself 3 times gives you 27. So cube root of 27 is going to be 3. And since this x equals 3 is coming from that x cubed term, that actually means it has a multiplicity of 3. So you've got x equals 0, which is twice. You've got x equals 3, which is occurring 3 times. So if you see, they add up to 5 answers, right? Which is what we should have since this was a 5th degree polynomial.
So would you actually write the 0 twice?
No. Just, yeah, just because, you know, they're repetitions basically. So you don't need to, your 2 answers in this case would just be the 0 and the 3. Well,
So it makes one just be a 3.
technically, yeah. But we don't, like he was asking, you don't have to write it down multiple times. It's just the idea that it's 3 times 3 times 3, which gives us 20. Okay, did anybody have any other question on number 2? So this was solving by factoring. Okay, let's go back. No, I don't want to switch. Go away. Okay, now here we're looking at something just a little bit different than what we talked about square roots before. So in this case, we're talking about complicated equations that are involving square roots. That actually means you will have the square root in your equation, and to get rid of that square root, we'll need to square both sides of our equation to try and get rid of that square root. And this actually works with cube roots, you know, fourth root, fifth root, any of those higher roots, you would use the same technique. But they are saying when you do this, what happens is you actually end up getting an extra answer. So when you end up taking that square on both sides of your equation, you end up getting an extraneous root, which means this is a root which will solve the new equation that we created after we took square on both sides, but it's not going to be a solution to the original equation you started out with. So that's why it's called an extra root or extraneous root. So what happens in this case is that we will actually need to remember to check our answer. Once you get all the solutions, you have to check your answer, because if it's an extra root, obviously we need to leave it outside, right? We need to discard it. We cannot include it as part of our solution set. So the first thing, of course, will be start by isolating your radical term on one side, get the other terms, if they don't have radicals, on the other side. Go ahead and square both sides of your equation, and then, of course, you're trying to solve. Every now and then, if you look at that step number 3, they are saying you may have to go back and isolate any of the radicals you may have left over by then. So I think we actually do look at an example when that happens. So you have to remember, we may have to do this a couple times to get rid of all the radicals that our equation will have. So let's look at our first example here. That's number 3. You've got square root of x plus 12 equals square root of x. Okay, so remember what I said, isolate your radical, so get that square root of x by itself on one side. Which means we need to start by subtracting that 12. And now you have square root of x by itself and x minus 12 on the other side. Now this is what I was talking about. So since we have that square root of x, we need to square both sides of our equation. And that means you will end up doing square over here and square on that entire x minus 12 on the right-hand side. Now on the left, the square root and the square cancel each other out. So we end up getting just an x term. What are we going to need to do on the right-hand side where you have x minus 12 and that whole quantity to the second power? So what would that end up giving you? Are you talking in terms of like square on the x and square on the 12? No. No, I don't think that would work either.
Would the square root just stick to 12?
No, it's actually on the whole thing, right? Which means what you're actually doing is you're taking that parentheses part and multiplying it into itself 2 times, right? Because that's what a square means. So that actually means you're going to do, what's that magic word again? FOIL, yeah. So you cannot just distribute that square. You have to do multiplication here. So FOIL will end up giving us what? Mm-hmm. Plus 144. Yeah, I think I need more space there. And then combine your middle terms, which ends up giving you negative 24x. Very good. So once you multiply that, and this is just our scratch work here, you end up getting x squared minus 24x plus 144. And we still have that singular x on the left-hand side, right? So you need to go ahead and bring that to the right-hand side, combine your terms. So I would subtract that x, get 0 on one side. And what does the right-hand side end up becoming then? Very good. So x squared minus 25x plus 144. Always try and think about factoring, but the idea is would factors, two numbers that multiply to give you 144 also add up to give you negative 25. 144 would be one of the easiest ones would be what we just did, right? 12 times 12, which we know will not add up to give you 25. You can go through other combinations of 144, but there's any one more.
The extra root, you have to check the answer and just forget.
Right. So that will happen after we get the answer for x. And then, yes, we really need to remember to check. And, you know, that's one of the places where I have seen students lose points on the exam because you went through the whole math, you got your answers, but you failed to check your answer. And so what happened was you got one answer which worked, but then one which was an extra one that you did not check and discarded out. So you end up losing points on that. So are there any combinations for 144 that will give you 25? Very nice. 16 times 9 gives you 144, and 16 plus 9 gives you 25. Now, if factoring did not work, what else could you have used? Yeah, you could have used the quadratic formula to help you out. All right, so it's adding up to be a positive, multiplying to give you positive 144, but adding to give you negative 25. So what should we do on 16 and 9? Very nice, they should both be negative. So when you factor this, you will have x minus 16 as one of the factors and x minus 9 as the other factor. And of course, you're back to the zero factor property, right? Take each factor, set it equal to 0, and those two numbers will be? So among these two answers, we have to check and see which one satisfies the original equation and which one is going to be the extra root, or do both of them end up working for the original equation, which I have a feeling they won't. All right, just to show you the original equation. So that was that square root of x plus 12 equals x. So this is the one you're going to check your answers in, okay? So let's get back and check our answers. That's square root of x plus 12 equals x. We'll start with x equals 16. Replace your x values with 16, and what do we end up getting? What is square root of 16? Very good. 4 plus 12. Okay, so this guy is giving us a true statement, which means 16 is a good candidate. He works in the original equation. Now let's check for x equals 9. The same thing, square root of 9 plus 12 equals 9. Square root of 9 is 3. And 3 plus 12. Very good. And 15 does not equal 9. That's a false statement, which means this guy is our extraneous root, right? So the one that does not work is the extraneous root that you came up with, which means your solution set, very good, will just be the 16. I cannot stress this enough. Please make sure you check your answers on this one, because you end up losing half a point or 50% of your point for that problem for simply not remembering to check your answers. So please be very careful on this guy. All right, so just to kind of again recap this, you started out by moving that 12 to the other side because we wanted to get the square root of x by itself. Then to get rid of the square root, we end up doing square on both sides, so they cancel out here, leaving us with the x. And then please remember to FOIL that right-hand side. You ended up getting x squared minus 24x plus 144, move that x to the right-hand side, which gave us the x squared minus 25x plus 144. And then we factored from there, set each factor equal to 0, and then check both our answers to make sure they would work in the original equation. 16 worked, we kept it. 9 did not work, it got discarded. Okay. Now number 4 is actually going to be one of those problems where we'll have to repeat the process because we've got two terms that have a square root on them. So in this case, what I would do is get that square root of x to the right-hand side and leave the larger one, the square root of 3x minus 2, on the left-hand side. Okay, so we have square root of 3x minus 2 minus square root of x equals 2. So as I was saying, start by moving that square root of x to the other side, which leaves us behind with square root of 3x minus 2 equals, you can write it as 2 plus square root of x, you can write it as square root of x plus 2, it really wouldn't matter. So we've isolated at least one of those radical terms, right? We've got the square root of 3x minus 2, which means we are now ready to square both sides of our equation. It will work on the left-hand side because my square root and 2, or the square, will cancel out, leaving us behind with 3x minus 2. But this is going to be the same thing on the right-hand side. You are still going to have to FOIL that right-hand side, right? Because it's a binomial term with the second power. So when you do FOIL, what will you end up with? Yeah, yeah, very good. So with the FOIL, we end up multiplying for the first terms, which is 2 times 2, that will be 4. Then you're multiplying 2 times square root of x, and as Levi mentioned, it will actually just be 2 times square root of x. It wouldn't go inside or anything like that. For the inside terms, it will be the same thing. We're going to do x square root of x times 2, which will also be 2 times square root of x. And then what happens on that last part where you're doing square root of x multiplied with square root of x? Yeah, it's going to become x. Because you are doing square root of x times square root of x on that last part, right? Which will end up becoming square root of x to the second power. The second power cancels out with the square root, giving you just the x. So it's going to end up cleaning up because these guys cancel out. Adding those two middle terms will give you these two. Come on, guys, what's 2 plus 2? 4. Yeah, literally, that's all. 4 and square root of x. And then that x at the end. So this guy multiplies down to 4 plus 4 square root of x plus x. Okay, so I actually want to go back and show you those instructions one more time. So this is kind of where they were talking about isolate or separate any remaining radicals, and you have to square again, which means our next step is actually going to be to get this square root of x by itself. I would probably start by moving the x with that 2x term, move this 4 with that 2 and clean out as much as I can. And once I get rid of the x and the 4, then we'll worry about this guy, 4 square root of x. So let's start by subtracting that x. So 3x minus x? 2x. 2x, very good. And then do the same thing with that constant number 4. So subtract 4 on both sides. Ooh, -6, right? Oh, yeah. That's all right. Okay, so kind of cleaned up. You've got your 2x minus 6 equals 4 square root of x. Now you can divide both sides by 4. If you want to avoid fractions at this stage, you can actually leave the 4 with the square root of x. It's not going to make a big difference. So you tell me what you want to do and we'll move forward accordingly. Do you want to divide by 4 or leave the 4 where it's at? You want to leave the 4? Okay. So this is the reason why we can leave the 4. It's 4 times square root of x. Yes? It's not 4 minus square root of x. It's not 4 plus square root of x. So since there is no sign in the middle of 4 and square root of x, we know it's being multiplied. And since it's being multiplied, you can actually leave it with the square root of x, but I still have to get rid of that square root, which means I still have to square both sides. And this is kind of why I didn't want to divide by 4, because if I divided both of these terms by 4, I would be having fractions here. And it's just a way to avoid fractions. That's the only reason why we're keeping the 4 where it's at. Okay, so now be careful over here. This 2 applies to the 4 and the square root of x, right? So the 2 will cancel out with that x, but it still stays on that 4. So be careful when you're doing this right-hand side. So 4 squared will give you 16. And what happens with the square root of x? Very nice. Yeah, so it drops down to 16x because that 4 squared is where that 16 is coming from, and then the square root cancels out with the square, leaving you behind with this x. We'll need to go back and FOIL the left-hand side, right? We still have 2x minus 6. So, yeah, this one goes forever. It definitely does. Okay, so what will that guy end up doing? 4x squared minus 12x. Very good. Yeah, plus 36. Very good. And yeah, exactly. When you add the middle terms, that ends up giving you negative 24x. Okay, so our left-hand side, 4x squared minus 24x plus 36. You want to set this equal to 0. So what do? No, not divide. Yeah. Yeah. Subtract the 16, which will go under the 24x. On the right-hand side, we will have 4x squared minus 24 minus 16. Yeah, negative 40x and plus 36. Okay. Let's just kind of recap what we have done so far, and then we'll come back and simplify. Extraneous? Yeah, it will definitely happen. Because you know what happens is anytime you do that square, you are building in an extra answer, because now what's happening is we didn't originally have a x squared term, right? But by doing the square on our, we have created an x squared, which automatically leads to creating an extra answer. So that's kind of what happens. Okay, so as I was saying, let's recap that and then we'll solve that last quadratic equation. So since we had two radical terms in there, that automatically told us we will have to do this twice. So the first thing we did is move our square root of x to the other side, and then apply your square on both sides, which helped us get rid of the square root on this first term. But that meant we actually have that square root still left behind. Now the right-hand side needed to be multiplied, so we FOIL that, which ended up giving us 4 plus 4 square root of x plus x. So now we have this as our equation right now, and our goal was to actually try and isolate that square root of x the second time. So we started out by moving our constant from 4 to the other side. We moved our x to the other side, cleaned it up as much as we could. The only reason we did not divide by 4 here was so that we wouldn't have fractions on the left-hand side. So that's why we left the 4 here. We did that square on both sides. Again, we need to FOIL the left-hand side, which ended up giving us 4x squared minus 24x plus 36. Since you have 4 and square root of x on the right-hand side, the second power applies to both numbers. The 4 squared gave you 16, and then square root of x to the second power is where that x came from. And then we moved our 16x to the other side. Cleaning that equation up gave us this final expression that we're looking at, 4x squared minus 40x plus 36. So again, at this point, this is a second degree polynomial, a quadratic equation. You can use quadratic formula to solve it. You can try simplifying the equation. You can try factoring. So I'm actually seeing something that's common between 440 and 36.
4.
And 4, right? So 4 would actually go into all of them. So again, like I showed you before, if you divide each term of your equation by 4, which of course includes that right-hand side also with the 0, you end up getting what happens to the first term. Yeah, just x squared. Okay. For the middle term, very good. 4 goes into 40 10 times. That will become 10x. And 4 goes into 36. Very good. 9 times. And of course, 0 divided by 4 is 0. So now you're working with much smaller numbers, which makes our life easier to try and solve it also. But you could have used the 4x squared, 40x, and 36 to help you out. This guy will actually factor. Yeah, so you could have done that, but remember you would also need to remember to factor out that 4x squared, right? So it would either break down into 2x and 2x or something like that. So yeah, it would definitely work on that expression also. Okay, so think about two numbers that multiply to give you positive 9 and add up to give you negative 10. Okay, so they will multiply to give us positive 9 and they will add up to negative 10. Yeah, very good. So that means you are looking at x minus 9 and x minus 1. So then what will our two answers be from here? Very good. Take each factor, set it equal to 0. And then, of course, we still got to check. It is a very long problem. And that's because, we're repeating that process of isolating our square root. So it takes basically double the work to get it to this stage. So which one of those numbers is it? Yeah, oh, I think this first one is, no, that's for the final. I usually don't do 30 for the chapter exams. Is it 20? I think it might be 20. Or because one of those exams is 25 questions, but it's not the first one. Chapter 4 or chapter 3? Yeah, one of those middle exams, which is 25 questions, but I think this one is going to be 20. Okay? Okay, so remember, you are checking these two answers in your original equation, which is this guy here, square root of 3x minus 2, minus the square root of x equals 2. So let's write that down. 3x minus 2 minus square root of x equals 2. Please, what did you say? 9 works? Alrighty, very good. So just a quick check here. Okay, so 3 times 9 will be 27 minus 2, 25. So square root of 25 will of course become 5. Square root of 3. And that gives you your 2 equals 2, right? Alright, this guy works. And the 1 doesn't, okay? Okay, so that's 3 times 1, which is 3. 3 minus 2 is 1, and you're actually getting 0. Ah. This is our so this one number. Again, that ends up working. Okay, so I know that was a long problem, but did anybody have questions on the process of that?
When we do this, are we supposed to include this and then also making sure that we make it clear that X
No, so that means when you write your answer down, in the answer box, you just need to remember that you're only putting in 9 and not the 1. But when you solve it, of course, you get both of them, but then the checking is to see which one you put as the final answer. And that'd be the same thing on homework. Because you know how if you type in incorrect answer, it pops up with that error message or something. So that's what will happen when you're doing this for your homework and quiz. Is if you put both answers in, it's going to count it wrong. But since you guys will be doing a paper test for the exam, obviously doesn't tell you anything. So that means I will be doing the grading, and you will be losing the point if you put both. You just got to remember to check your answer for these guys. And these are the only problems where checking is absolutely necessary. Is where you have these square roots as part of your original equation, right? Any other question about these examples?
both are right, like you can have both
If both are working?
If you study the calculator one, if they're both working,
Yes, especially for this type of problem where we ended up doing it twice, I would check both of them because in that case, sometimes you can have both of them working. But for the first one, usually you only get one. But you know what? Again, they kind of throw different ones at you. So I would say to be on the safer side, go ahead and check both the answers. And sometimes you can actually just plug them into your calculator and see what you're coming up with if you're getting the same answer or not. So it doesn't have to be a very formal process, but just make sure you have checked your answers for the original equation. Okay, so when we're talking about rational exponents, that actually means in your exponents, you're going to have fractions in there, right? Rational numbers, which is the form of A over B. So here they're talking about how do you solve an equation which is raised to a rational exponent. So the idea is if your original equation is x to the power of m over n equals k, that means you will take both sides of your equation and raise it to that reciprocal power, right? So if it's m over n, you're going to actually raise it to n over n. So that means you invert your exponent and apply it to both sides of your equation. Now they are saying, remember that there are two real even roots for any positive real number, and there is exactly one odd root for any real number. So they're actually talking about in terms of if you have square roots, you end up with two answers, right? Because you always get that positive and negative root. And then if you have an odd root, like the cube root, you only have one answer. The cube root of 27 is only going to give you 2, right? It's not going to give you positive and negative 2. Cube root of negative 27 gives you an answer of negative 2. Cube root of positive 27 gives you an answer of positive 2. But with square root, that's not the case, because square root of 4 can have both positive and negative 2 as the answer, right? Because of that sharing property. So that's kind of what they're talking about here. So they're saying if m is an even number, which is that numerator value, and your k is positive, then as you can see, since m is an even number, you're actually going to end up getting two answers, the positive and negative answer from here. Now, if m is an even number and your k is negative, this number is negative, technically that means you're going to get imaginary solutions, right? So that's why they are saying you will have more real solutions, because now you're working with imaginary numbers and not real numbers. But if this n value here, the numerator, is an odd number, then you are actually going to get 1 to reason out of that. You're not going to get that positive and negative like we do with evens. And when we actually look at this example, I'll talk about why it makes a difference. So look at our example 5 over here. You've got x raised to the power of negative 4/5. So you can see my numerator value 4 is an even number, right? Which means you are looking at step 3 where you are going to end up getting one positive and one negative answer, and in this case. And let me show you why that happens. So number 5. No, because 16 is not negative. If 16 was negative, that's when you're running into imaginary. So 16 itself is positive. We will still have real number solutions. We have x raised to the power of negative 4/5, 16. Okay, so they're telling us take both sides of your equation and raise it. Do I want to do it with a negative sign? Yeah, I think it would be better. So let's invert that, and 4/5 will become 5/4 and keep the negative sign. And then we'll have 16 also raised to the power of negative 5/4. Okay. Have you guys worked with rational exponents before? Yeah, in my math lab, but before that, like before this class? Okay, so let me give you just a quick explanation on that and show you why we're actually going to end up with that positive and negative answer here. So when you have this expression in the form of m over n as your exponent, that actually means your x has the exponent of m, but that denominator value is actually telling you which radical you are looking at. So that denominator n actually tells you, do you have a square root or a cube root or a seventh root or whatever. So what's happening here when we did x raised to the power of negative 4/5, but we invert that, right? We make it negative 5/4. That actually means you are looking at, and I'm just going to show this to you in general terms. If you have negative 5/4, that means you are looking at 4th root of x to the negative 5. So 4th root is basically the same idea as your square root. Because it's an even again, you are going to get that positive and negative answer. Because think about it. If I take negative 2 to the 4th power, what do I get? 16. And positive 2 to the 4th power is 2. So 16 has 2 roots, right? Positive and negative 2 raised to the 4th power can still give me 16. So the same idea with square roots. Both these positive and negative 2 lead me to the same answer. So when I'm doing the 4th root, I have to take into consideration I will get one positive and one negative answer. And that's exactly what's happening here. Because once you inverted that exponent, the 4 became the denominator, which means I was looking at the 4th root of these numbers. Now on the left-hand side, do you know what the rule is when one base has 2 exponents? So you have x with one exponent, negative 4/5, and that whole thing is raised to negative 5/4. So when you have, yeah, you multiply them, right? So you're actually multiplying negative 4/5 with negative 5/4. What will that end up becoming? Positive 1. Yeah, exactly, because these guys will cancel each other out. 2 negatives will become positive, giving you 1. So that's why we use this technique, so that you are getting rid of that exponent on the x value. Now we have a nice and clean x. But on the right-hand side, since that's negative 5/4, to make it positive, we bring that 16 down to the denominator level. Make it 1 over 16. And by doing that, we're converting it from a negative exponent to a positive exponent. Again, these are all coming from rules of exponents. If you are feeling like, okay, I'm a little rusty on those rules, just Google them and you should be able to look at them.
Did you take the 4 and do what you were saying there?
The 4th root? Yeah. Yeah, you can do that. And then you can raise it back to that power of negative 5. You'll still get the same answer. And, that's kind of the beauty that I like about math is there's not just one way of approaching a problem. There's so many different ways. So whatever you're comfortable with, you simplify it, you can do that. So again, we had 16 ways to the negative 5/4 power to make it into a positive exponent and putting it in the denominator of 1. It makes it 16 over 5/4. You can do this by hand. You can use your calculators, however you want to simplify it. But basically the idea is, and again, I'm going to do this as scratch work on the side. But right now we've got 16 to the 5/4, which is the same thing as 4th root of 16. You can think of that 5 being on the outside because I think that's going to be the easiest way to simplify this. We've already talked about, and I honestly didn't think about it, then I would have used something else other than 2 here. But you can see when you take the 4th root of 16, we're getting 2 as our answer, right? So that's going to be 2 coming from the 4th root of 16, which is raised to the 5th power. And what is 2 raised to the 5th power? 32. But don't forget, since this is the 4th root of 16, you are going to have positive and negative. So your final cleaned up answer is going to be positive or negative 1 over 32. So that positive or negative is coming from the 32, right?
You have to put the 1 of the 32.
Yes, because we have to do that to make that exponent into a positive exponent. Yeah. So that was just to show you how you can clean up the denominator part, but it's still going to end up being 1 over 32 for that.
From X equals 1 over 16 like that. And that without using the red section.
Oh, okay. All right, I will get to that, but let me start at the beginning. So your clue here is how do I start solving a problem like this? Is whatever is the original exponent on your x value, right? If it's negative 4/5, you are always going to invert that fraction and make it 5/4. If it's a negative sign, take the negative sign with you because we don't want any negative left behind as an exponent on our x, right? So we took that negative 4/5, made it into negative 5/4, and raised both sides to that exponent. These guys multiply out, they basically cancel each other out, giving you x to the 1, which is x. And then, of course, that meant when you became the right-hand side, you have 16 raised to the power of negative 5/4. So in your little instructions, they were telling us if 16 was negative, you would not get a real solution from here, right? Because this is where you would run into imaginary solution. If R16 is positive, we are going to get a real number solution. So now to simplify this, since this is a negative exponent, to make it positive, we place it in the denominator of 1, you end up getting 1 over 16 to the power of 5/4. Now the idea is you're taking 16, raising it to the 5th power, whatever that number comes out to be, then you're taking the 4th root. So that would be one way of doing it. So if you took 16 and raised it to the 5th power, and let me actually show that to you down here. So first you raise it to the 5th power, and then you take the 4th root, which is going to be really, really large value because 16 raised to the 5th power, yeah, 1048576, and then you are taking the 4th power on that, right? Oh, and let me think what this calculator does. 4 root of that number. And then when you take 4th root of this 1,048,576, you should end up getting 32. So that would be the other way of doing it. So I like to do it the first way I showed you, which would be do the 4th root first and then raise it to the 5th power.
So if you do get an imaginary, do you want us to solve it if you have it on the calculator?
Yeah. So you would still have to bring that negative outside as I and then simplify your number. Do you remember if my math lab gives you imaginary?
Only on specific questions that it doesn't.
I can't remember for this one.
You can just have
Just
drop down box.
okay, so you won't have to actually solve it. Okay, so this may be one of those questions you'll have to see if they actually want you to solve the imaginary, or does it just give you that option of saying imaginary and you're done.
One solution,
Okay.
double solution, or just no solution.
No solution. Okay. So you kind of see what my math lab does, and if something throws you off, we can do that. Okay, so as I was saying, you still need to clean up that denominator. So you can either do 16 to the 5th power first, which gives you this 1 million something number, and then take the 4th root on that. Or you can do the 4th root first, which of course means we're dealing with smaller numbers, and then raise 2 to the 5th power, which would end up giving you, because remember that 16 to the 5/4 is in the denominator. Whatever answer you get will stay in the denominator. So you are always going to have 1 over whatever that cleans up into. If you had started out with a positive 5/4 here, then your answer would just have been positive or negative 32. But because of that negative exponent, you automatically went down to the denominator.
Four is now the exponent. So
Yeah.
so if we have negative 7 over 3, so 3 would be.
Yeah, exactly. So it's just whatever ends up becoming your denominator after you invert it. That decides if you're going to have 2 answers or 1 answer.
For the other way that we did it, the 16 to the 5th power, would we still have to write the 32 as in 1 over 32, or would it just be 32?
No, it's still going to be 1 over 32 because we've already brought that 16 down to the denominator. So yeah, that answer will still stay in the denominator. Yeah, very good. Anything else popping up about this example? Okay.
Is there any rule that we use when we're using equations that would not put 1 over?
If you didn't have that negative sign on the 5/4, let me go back. Yeah, so if you didn't have this negative sign here, you would have stayed on the numerator. Yeah, you wouldn't have had 1 over. Very good.
Wait, what do you mean by that?
Okay, so you see how the original had a negative, right?
Yes.
So when we inverted that fraction, we still had to take negative, which means we had a negative sign here. But let's say this guy was just x to the positive 4/5, then this negative sign would not have happened. Yeah. Yeah, and you would have had plus or minus 32, not 1 over. So that 1 over 32 is simply happening because of this negative. Okay, very good. Exactly. Yeah, you would just be working with whole numbers or integers, I guess, in this case. Anything else? Okay, very good questions, guys. Good job. At the beginning, that's your first step.
Okay.
Yeah, because you are getting rid of that exponent on the x. You want to get x by itself. You don't want any exponent on that, and that's the first step you're going to do is invert your exponent.
Okay.
Okay. All right, so this one is talking about equations that resemble your quadratic type. Now remember, your quadratic type is the ax squared plus bx plus c equals 0. But in this case, they're actually higher degree polynomials that we're going to convert and simplify them by putting them into some format like this, so that I can actually use the techniques of quadratic equations to solve this instead of inventing a new method of solving these guys. So basically they are saying you will take an equation and convert it to a quadratic equation by substituting a variable, or you can actually even do an expression. It just does not have to be a variable. So this is what we're calling as equations of the quadratic type, where you have to define your u in such a way that I can take it from x to the 4th power and make it look more like a quadratic equation here. So the idea is, depending on, you can kind of see the different forms of equations we have here, each one of these are different. So how can I take something like this or even something like this and make it look like a quadratic type of an equation? And that actually comes down to how do you define that u term for your equation. And the easiest thing I can tell you for identifying what u should be defined as is actually coming from the middle term. If my middle term is x squared, that's what my u value is going to be. If my middle term here is x squared plus x, that's going to be my u term. My middle term on number 8 is x to the 1/3. That's going to be my u term. So it's actually the variable part of your middle term, which tells you what you're going to define that u as. So let's look at this first example here. Okay, so we've got this will be number 6. Okay, so by default, you are given x to the 4th minus 9x squared plus 20 equals 0. So like I said, that middle term is going to tell us how we're going to define our u term as, okay? So we would say let our u term be x squared. But now how do we give it that format of au squared plus bu plus c equals 0, right? Which means we're going to have to find a way to rewrite that first leading term so that it's only a second term exponent, right? So think about that. You have x to the 4th. Yeah, so if I'm defining u as x squared, which means I can write this as x squared to the 2nd power, right? 2 times 2 will still end up being 4. So what's going to happen is you're actually going to rewrite your x to the 4th as u to the 2nd power, because again, think about it. If x squared is u, that's going to become u squared. Do we see how that transition happens? Because I don't want to move forward till everybody's comfortable.
So just on things, if we did
No, it will actually be 9u because you would still have to use the u instead of the x squared. So it will be, yeah. Yeah, you're literally just substituting. So instead of x to the 4th, if we're breaking the x to the 4th down into x squared to the 2nd power, and we're defining u to be x squared, that means that becomes u and then your square goes on the outside. So this will become u squared for the first term minus 9, which was our coefficient, but will the x squared be replaced with u, plus 20 will stay the same, 0. So we're literally just substituting. Substitute in our equation. This will just be scratch-work here. So instead of x now, we're using u as our variable, right? And we'll come back and clean that up towards the end. But now, since this is a 2nd degree polynomial, I can use factoring, I can use quadratic formula, I can use any of those methods that we saw in the previous section to simplify this guy, which this guy will actually factor, because think about two numbers that multiply to give you 20 and add up to -9. Yeah, very good. And what will the signs be on those guys? Because if you do positive and negative, you won't get -9 then. Very good. Both have to be negative. All right. And that will be u minus 4 and u minus 5 as our factors. So again, when we get into factored form, remember you use your zero factor property to separate them. So that would be u minus 4 equals 0 or u minus 5 equals 0. Move that 4 and 5 to the other side. And we end up getting u equals 4. Yes, you will need to, because our original variable was still x. So this was just to clean it up a bit. Okay, so we had, after our substitution, u squared minus 9u plus 20. We used factoring to break them down, which comes out into -4 times -5 gives you positive 20. -4 plus -5 adds up to -9. Take each factor, set it equal to 0, and you end up getting u equals 4, u equals 5. Then you go back to that substitution. So we define u for x squared. So you will now replace your u down here with x squared equals 4, or x squared equals 5. So we need to, in a way, we're resubstituting it, right? Putting it back in the original form. Remember what I was telling you earlier. So since this guy is a 4th degree polynomial, that means technically we should have up to 4 answers for this. But then we also talked about multiplicity. Sometimes multiplicity doesn't give us all those answers. So what do you think once you simplify your x values come out to be?
I got 2 and then plus or minus square root of 5.
You're missing an answer. You're so close.
So -2.
Yeah, you'll have plus or minus 2 also, right? Because you're still doing x squared, which means you still end up doing square root of x to get rid of that square, which means from that square root, you end up getting a positive and a negative. You end up getting x equals plus or minus 2. So that's 2 answers from there. And then, of course, same thing with the 5. Taking a square root plus or minus. So you will have your 4 answers in this case. You can put them in whatever order you want to put them in. Because we applied the square root, yeah. So we started with the u substitution first, right? We used the variable part of our middle term to define what u is going to be. So since my variable was x squared in the middle term, that's exactly what my u is going to be, which means rewriting this in u terms would end up making it x squared to the 2nd power or u squared. So the leading term becomes u squared minus 9u plus 20 equals 0. Factor that, take each of your factors, set it equal to 0. And basically, once you have solved it for u, you got u equals 4 and u equals 5, then bring back that substitution of x squared and then get your x values. Because if you try to factor a 4th degree polynomial, it takes a lot of trial and error to see what those combination of those 4 numbers is. And imagine trying to think of, oh, I need to have a square root of 5 in there for my factor, right? It's not an easy number to play around with. So this is what we call as u substitution, or your equations of the quadratic type, where we try to use this idea in there.
Well, in my math lab, it doesn't say.
Like what type to use?
Well, it says use the substitution method to solve.
Okay.
It doesn't say.
Okay, it doesn't tell you that. Okay. So basically what you are looking for is you should have, I guess, double the exponent here, because this only works if you can write this guy as u and this guy is u squared. So you can have x to the 3rd, x to the 6th here, of course, x to the 2nd, x to the 4th. Or if you look at example, oh, no, what did I do? Okay, here you will have, basically, if you look at the middle term, it's this parentheses part, right? X squared plus x. But then this one is raised to the 2nd power. So it's to, well, not technically double, but to the 2nd power of that, right? here again, even though these are rational exponents, if I take 1/3 and multiply it by 2, I get 2/3, right? So the exponent is the double for that. So that's kind of the format you are looking for. And then, they still have to be trinomials, right? They still have to be 3 terms, because if you put, like we saw the first example, you can't have 4 terms in there with the x cubed and the x squared and the x term, because then you're not going to be able to use the quadratic type. Because remember, quadratic type is 3 terms, right? Ax squared plus bx plus c. So you can only have 3 terms if it's going to be a quadratic type. The first one should be a square, middle term will be just the x term, and the last one is constant. So it still has to follow that format. So that's what you would be looking for. Okay? What else? Yes?
Why do we make it a I? Why do we put an I?
For the square root of 5?
Yeah.
Because we didn't have a negative sign inside. So if this was -5 to begin with, and you would end up with negative inside the radical, that's when it would be 5.
So
But since you didn't have a negative in there, this is not an imaginary number. Yeah.
Okay.
Yeah, very good. What else?
Is there any substitution method or anything that is quadratic that's more than 4 terms or 3 terms? So anything that's outside?
It wouldn't work with this type of problem then. Yeah. Unless you can simplify it, like combine terms.
Make it 3.
Yeah, where you make it 3, but but if they give you all different exponents on those variables, then it's impossible for us to do that. Then we would probably fall back to that factoring method by grouping that we saw at the first example on this handout. What else, guys? All right, so we don't really have much left in 6. Obviously, we need to finish these examples, and then 1.7. So obviously, we'll keep that for Monday. Finish our chapter 1 on Monday, which means for Wednesday, you guys are definitely